Hello, fellow Econauts, and welcome back to our show. I'm here with my brother Ben, the Rocketman. Hey, Ben, how are you?
Hey Simon, hey fellow Econauts, how's it going? Today we talk about batteries in space.
So what kind of batteries are we talking about today?
Well, today we talk about RTGs that are very special batteries that are very long lasting, and that is what we need in space for long missions.
What are RTGs and how do they work?
That's a simple and not so simple answer. RTG stands for Radioisotope Thermoelectric Generator, RTG. And in principle, we send radioactive material, or we have radioactive material that heats up because of the decay, and a thermocouple. That thermocouple usually you use it to read temperature, but in this case, the temperature is so high that we actually get an electric signal, and that signal we don't use as a signal, but as actual source, power source. So we can use now radioactive decay that makes heat, and the heat makes electricity, and that is very long lasting. So yeah, these batteries, they are very powerful.
What kind of applications are RTGs used for?
I mean, obviously, we are a channel talking about space applications, so I think it's obvious to say for space exploration and space missions, but also on Earth for very harsh environments. RTGs are a very useful form of power source if you have to run a robot or a rover or something like that in that harsh environment. In space, they are very often used because they're also because of the heat they are generating. They are also generating heat for all the electric components on the RTG, which means they are like, let's say you would build a rover and you would like to send that rover to the moon. If you don't have a heat source on board, usually that rover is likely to die during the lunar night. So with an RTG, additionally to the actual power source for providing electricity, you also have a certain amount of heat produced, which also saves the components. And because the RTG also doesn't use any moving parts, it's actually quite simple to put it into your rover as a source of energy. However, because we're using radioactive material, and because plutonium and other radioactive sources and elements are very heavy, obviously now we have to pay off with a more complicated way to actually launch it into space.
Maybe you can tell us a little bit about the advantages and disadvantages using RTGs in applications.
Let's stick with space applications. So and let's start with the advantages. So coming back to that example I made, building a rover, for example. When you build a rover and you send it to the moon, obviously you need the rover needs energy, electricity in order to run. So or you would have to provide anything else like another fuel. Obviously it's a bit harder to refuel with petrol, diesel, or hydrogen or whatnot in space, where you don't have a refuel station at every corner. So therefore usually there's other forms of power needed to provide that energy, that electricity. So one way could be actually sending or putting a solar panel or solar panels onto the rover. But now you have the disadvantage that obviously a solar panel can only provide energy when the sun is shining. So a lunar night, so that is one night, one lunar day, one lunar night on the moon, lasts for 14 days. So that's why we see the full moon every 28 days, because it's one lunar night, one lunar day. So every 14 days there's the sunset and the sun rises. That means for 14 days you have no sun if you have a rover on the moon. So now how do you provide the energy in that time? Even if the rover is just on standby, all the electric components on the actual rover, they still need some energy in order to keep warm enough to not freeze to death. So a solar panel alone will not provide you enough energy if you send that rover now on the moon. So how to circumvent that? Either you have to put a battery on that, so the solar panel can actually recharge that battery, but now you have to send a large battery. Or instead of sending a solar panel with a battery, you could use said RTG. The RTG has a very large amount of energy, so that you don't have to recharge it. It will run for a very, very long time. So you can run your space mission and longer. In fact, the Voyager 1 and 2 are using RTGs since the 1970s, and they haven't been recharged since. But yeah, the disadvantage obviously is once the fuel is used, the fuel is used. So you can't really recharge and refuel an RTG very quickly. You have to replace the whole thing. And another disadvantage is obviously, as I already mentioned a little bit before, we are talking about radioactive decay. So therefore, extra measures of safety are required in order to shield the rover so that it doesn't radiate anything in its environment. It makes it a bit harder if you have sensors on board, because these sensors, they need either to be shielded, they need to be able to run in that environment with a radioactive source as a neighbor, straight neighbor, or you have to shield it perfectly. And also because of the materials much heavier than other materials, it makes the rover heavier, and therefore the cost to actually send it somewhere to the moon or anywhere else makes it more expensive.
Well, it seems like RTGs are a very good source of energy for spacecrafts like the Voyager 1 and 2. I learned a lot today, and I hope you too. If you liked that episode, please don't forget to leave a like and subscribe if you haven't already.
And if you feel recharged, then hit that notification bell so you don't miss out on new episodes. And don't forget, we also have a quite large library already of episodes. And if you're interested, watch them.
And I will see you next time. Bye bye.
See ya.